Welcome to Taming the Noise, a practical guide to conducted EMI in DC-DC converters. We will focus on mastering filter design to meet regulatory standards and ensure system integrity. Electromagnetic interference, or EMI, from switch-mode power supplies is a mandatory hurdle for market access. Failure to comply with standards like FCC Part 15 or EN 55022 can lead to costly redesigns and blocked market access. Conducted EMI is divided into common mode and differential mode noise. For typical non-isolated DC-DC converters, our focus is on differential mode EMI, where current flows between the line and return conductors. This graph shows unfiltered EMI from a DC-DC buck converter. The tall spikes represent noise at the converter's switching frequency and its harmonics, which clearly exceed the regulatory limits, resulting in a test failure. The industry standard solution is a simple, passive LC low-pass filter. The inductor, LF, is in series to block high-frequency noise. The capacitor, CF, is in parallel to shunt remaining noise to the return path. Designing an effective EMI filter follows a systematic four-step process. Quantify the noise, select the inductor, calculate the capacitor, and finally, dampen the system to prevent filter instability. Step 1 is quantifying the required attenuation to reduce peak noise below the regulatory limit. This can be estimated using a quick practical oscilloscope method or a detailed analytical calculation. Steps 2 and 3 involve sizing the filter components. Start with a practical inductor value, LF, then calculate the required capacitor, CF, based on resonance and attenuation conditions, taking the larger of the two values. Step 4 is the critical damping capacitor. An undamped LC filter creates a high impedance peak that can cause instability. A parallel damping network prevents this by flattening the impedance curve. Here is a proof of success applying the four-step method to a Texas Instruments evaluation board. The before graph shows non-compliance. The after graph shows emissions well below the regulatory limits. Repeating the process with a different converter, the LMZ 14202 validates the method's robustness. Again, the filter design successfully reduces the conducted EMI to compliant levels. To achieve consistent and certifiable results, conducted EMI tests are performed using a line impedance stabilization network, or LISN. The LISN provides a standardized measurement impedance for connecting a spectrum analyzer. To summarize, conducted EMI is a mandatory constraint. Use a damped LC filter for differential mode noise. Follow the four-step process for design, and always verify your final design using a LISN for certifiable results.